Welcome back to Best Academic TV. In this video, we're gonna focus on vector products. All right. Now, please write vector products can be divided into two. Vector products can be divided into two. The first one here is A. We have dot or scalar products. B. The second one here, class, we have cross or vector product. All right, let's consider the first one here. The first one is dot or scalar product. Please write dot or scalar product. Two vectors A and B, two vectors A and B is said to be in dot or scalar product. Two vectors A and B is said to be in dot or scalar product if only if they are expressed as A dot B. If only if they are expressed as A dot B. Means that whenever we see this expression here, it represents or it denotes scalar or dot product. If you have two vectors D and E and you are asked to find D dot E, that particular expression represents or denotes dot or scalar product. Please take note. So the question now is, how do we solve dot or scalar product? Before we solve the question here, class, let's know the laws of dot product. Laws of dot product, please write. Right, these laws will enable us to solve most questions in dot or scalar product. Okay, now let's consider the laws here. Please write. The law states that the dot of two like vectors is 1. The dot of two like vectors is 1. So whenever you dot the same vector, the result must be 1. Whenever you dot the same vector, the result must be 1. So we have the first law here. So let's represent this mathematically here. It means if I have I dot I is the same as having J dot J is the same as K dot K. So the result of this is 1. Please take note. What does it mean? It means I dot I is the same as 1. J dot J is the same as 1. K dot K is the same as 1. So whenever we see I dot I, that expression is not I square, it is 1. Whenever we see J dot J, that expression is not J square, it is 1. Whenever we see K dot K, that expression is not K square, it is 1. Please take note. All right. Now let's take the next law. The next law states that the dot of two unlike vectors is 0. The dot of two unlike vectors is 0. Okay. Okay, let's represent this mathematically here. If you have I dot J is the same as J dot K is the same as I dot K. So the result is 0. Whenever you dot unlike vectors, that is, whenever the vectors are not the same, please take note. Whenever you dot vectors that are not the same, the result must be 0. Please take note. Okay, now let's solve question 1 here to understand this law perfectly. Question 1, please. Let's take this question here. They said if P, vector P is equal to 7i minus 3j plus 2k, and vector Q is equal to 4i plus 5j minus 3k. We are asked to find the scalar product of P and Q. We are asked to find the scalar product of P and Q. That means it's the same as P dot Q. Please take note. Scalar product is the same as dot product. Please take note. So if I have two vectors D and E, and I'm asked to find the dot product of these two guys, it can also be expressed as D dot E. Please take note. So in this question here, we are asked to find the scalar product of P and Q. That means we are asked to find P dot Q. Please take note. Okay. Now let's solve this here to understand this particular question perfectly. We are asked to find P dot Q. Okay. Let's represent the vector P. The vector P is 7i minus 3j plus 2k dot the vector Q is 4i plus 5j minus 3k. Please take note. We're asked to dot these two vectors here. So class, this is the simplest way to solve dot products. What you have to do here is to expand. But when you are expanding, you only multiply the corresponding vectors. Please understand this. When you are multiplying, you only multiply the corresponding vector. Okay. Now let's multiply this. We multiply to its corresponding vector. That is the I here. This will multiply. J will multiply its corresponding vector. That is J here. Please take note. This will multiply. K will multiply its corresponding vector in this second part, which is K here. Please take note. So when you do that, we have the result to be 7. So in terms of the number, multiply the number. That is 7 is the number here, 4 is the number here. That will be 7 times 4. In terms of the vector, you say I dot I. The dot is this dot here. Please take note. Okay. So do the same thing here. This is the number. The number here at the front of J is minus 3. This will be minus 3. The number at the front of J here in the second part is 5. That is times 5. In terms of the vector, you say J dot J. So do the same thing here. This will be plus 2 into minus 3. In terms of the vector, it will be K dot K. Please take note. So class, let's multiply. 7 multiplied by 4 will give us 28. So remember the law that whenever you dot the same vector, the result will be 1. So this will be 1 minus 5 minus 3 times 5 will give us minus 15. Remember the law here. J dot J is 1. So plus 2 times minus 3 will give us minus 6. K dot K is 1. Okay. So class, 28 times 1 will give us 28. Minus 15 times 1 will give us minus 15. Minus 6 times 1 give us minus 6. So the result of this will be 28 minus 15 minus 6 give us 7. The unit of dot product is units. Okay. Let's solve the next product here. Please write cross product or vector product. Cross product or vector product. Let's know when two vectors is in cross or vector product. Okay, please write two vectors A and B is said to be in cross product if only if two vectors A and B is said to be in cross product if only if they are expressed as A cross B or A hat B. It means that these two expressions here represent vectors in cross product. It means that these two expressions here represent vectors in cross product. So you can either use A cross B or A hat B. So class, let's know how to solve vectors in cross product. Okay, let's take a question here, class. Question 1, please. We are given a question here, class, and they said given two vectors A equal to I plus 2j minus 3k and vector B equal to 2i minus 3j plus 4k. Find A cross B. All right. Now, to evaluate cross product, we apply matrix method. The simplest way to evaluate cross product is to use matrix method. Please take note. So how do we use matrix method to solve cross product? Okay. Now we have to solve this step by step. Okay. For you to understand this perfectly, all you have to do to get the full video here is to hit the subscriber button. Okay. Now let's consider the steps in solving cross product. Steps in solving cross product. Okay. The first step here in solving cross product using matrix method is this. Step 1. We transform or we represent the vectors in matrix. How do we represent the vectors in matrix? The first thing here, the first stage or the first row is going to be the vector ijk. So I will have something like this is my line. This is the row 1 will be I, J, K. Please take note. So the next here is to represent the numbers. The first vector is A. So I will represent the number of vector I in terms of A. So the coefficient of vector I in terms of A is 1. The coefficient of vector J in terms of A is 2. The coefficient of vector K in terms of A is minus 3. So the next is vector B. The coefficient of vector I in terms of B is 2. The coefficient of vector J in terms of B is minus 3. The coefficient of vector K in terms of B is 4. Please take note. So the next step, that is step 1, is to apply Cramer's law or Cramer's rule. Please take note. So we have to know what Cramer's law is or what Cramer's rule is. Please take note. In Cramer's law, it states that the first vectors will be assigned to a particular mathematical operators, that is plus, minus, plus. Please take note. Okay. So if you have something like this, class, I have something like this. This is I. This is J. This is K. We have this will be 1, 2 minus 3. This is 2 from the matrix minus 3, 4. So this is what Cramer states, that the first row here will be assigned an operator. So the operators will be plus, minus, plus. Okay. It changes plus, change to minus. The next is plus. Please take note. So I will have this part here to be plus. This is minus. This is plus. Okay. So this is what Cramer's rule states. Okay. These are the signs here. Plus, minus, plus. Okay. Now the next step here, step 3, is to reduce to 2 by 2 order of matrix. So we have this matrix to be in 3 by 3 orders. Okay, so in matrix we cannot solve 3 by 3 matrix until you reduce that to 2 by 2 matrix. Why? The reason is this. The reason is this. 3 by 3 order of matrix does not have formula, but 2 by 2 order of matrix has a formula. Okay, so we have to reduce this 3 by 3 matrix to 2 by 2 matrix to use the formula for 2 by 2 matrix. Okay, now let's reduce this to 2 by 2 matrix and use the formula for 2 by 2 matrix. All 3 by 3 matrix cannot be solved. They have to be reduced to 2 by 2 matrix, and we can apply the formula for 2 by 2 matrix before we can solve the matrix of 3 by 3 order of matrix. Okay, now let's reduce this to 2 by 2 matrix here. To reduce this to 2 by 2 matrix here, we have to make use of the Cramer's rule. Please take note. Okay, what does it mean here? It means that I will mute the first row. Please listen to me carefully. Since I'm taking the first part here, that is I part, I want to take the first part here is to take I part. Okay, but I will mute the first row, that is this first row, and mute the part of I, the one I'm taking, the row of I. I'll move the first row and move the column of I. When you do that, the values I'll be seeing is 2 minus 3 minus 3 4. Please take note. When you do that, we have this to be this will be an I, that is vector I, will be reduced to 2 minus 3 minus 3 4. So let's take the next one here. Plus the next one here is vector J, not only J minus J though. So I will close the row of the vector and close the column, that is the column of the J. So I'm going to have this to be 1, please just be careful, 1 minus 3 2 4. Okay, when you do that, we have the answer to be for minus J vector minus J will be class 1 minus 3 2 4. Please take note. So lastly, plus vector plus K. When you do that, what is the answer, please? From your own end, what is the answer, please? That is 1 2 2 minus 3. All right, now we have reduced the 3 by 3 matrix to 2 by 2 matrix. So we can now apply the formula of 2 by 2 order of matrix. Now, what is the formula for 2 by 2 order of matrix? The formula is this. That is the formula for 2 by 2 order is a primary diagonal minus secondary diagonal. Please take note. So the point here is for us to know what primary diagonal is and for us to know what secondary diagonal is. Okay, now a diagonal is just the half of a triangle, rectangle. Okay, if I have a rectangle like this, so to find the diagonal of this, I will divide this by half. The same thing here, please take note, I will divide this by half. So the starting point, which is this part here, will be primary diagonal. The ending point here will be secondary diagonal. So we can also create the same thing here. Please take note. We can create the same thing here. So this we go with this. This we go with this. This we go with this. This we go with this to create diagonal. This we go with this. This we go with this to create diagonal. Please take note. When you do that, we have this to be this is primary diagonal, this one will form secondary diagonal, this is primary diagonal, this part will form secondary diagonal, this is primary diagonal, this part will form secondary diagonal. So now let's multiply, class. 4 times 2 will give us 8. That is, this will be I into 8 minus, the minus is from the formula, please take note. Primary, 4 times 2 gave us the primary, minus from the formula, that is minus. Now let's get our secondary diagonal. This will be minus 3 will give us 9. So minus j, that is this j here. Now let's get this. 4 times 1 will give us 4 to get the primary. So minus, the minus is from the formula. The secondary will be 2 times minus 3, which is minus 6. So I will have bracket open minus 6. Please take note. To separate the natural minus from the formula from the minus 6. Okay. Now the last one here, class. Sorry for this. The last one here is plus k. Now let's get this primary diagonal. Minus 3 times 1 give us minus 3. Minus from the formula. 2 times 2 give us 4. Please take note. So class, this will give us 8 minus 9. Let's simplify what is inside the bracket here. 8 minus 9 will give us 1. Minus 1, sorry. Minus 1 times I will give us minus I. So minus times minus, let's simplify what is inside this bracket here, this one here. Minus times minus will give us plus. 4 plus 6 will give us 10. 10 times minus j will give us minus 10j. Okay, lastly here, minus, let's simplify what is inside this bracket here, class. Minus 3 minus 4 will give us minus 7. Minus 7 times plus k will give us minus 7k. Okay, so class, this is my answer here. So A cross B will give us minus I minus 10j minus 7k. All you have to do to get more video on vectors in 3 dimension is to hit the subscribe button. Okay, thank you.